It is evident from the past that quality information is the vital ingredient that supports timely decision making and leads to the success of an organization. However, the reaction time to act on information has been steadily decreasing over the years, thereby creating added pressures on people and management. If it took 33 years for the design of the steam engine to be actually applied, it took 7 years for the laser technology to be implemented. And in future, it will take perhaps a year or two between an invention and its application. Add to this the pressures of competition and quality assurance that managers today are faced with. Even though organizations have had systems of information for their management that may have been extremely efficient for the past, the same is grossly inadequate to meet the information needs of the present and the future. The question then arises, what information needs does a manager today have to manage effectively? The most basic and common need for all managers is to have an understanding of the purpose of the organization, its policies, programs, plans, and goals. Beyond that, the needs vary since every individual has different ways of viewing the information, using analytical approaches, organizing the relevant facts, and finally implementing the necessary strategy. In general, though, one can say that the information needs of people in management depend on the nature of decision they are required to make, structured or unstructured, the hierarchical level they occupy in the organization and the functions they perform, and the factors that are important for their success. Information needs for decision making depend on whether the decision being made is of the structured or unstructured type. A structured decision is usually characterized by being a routine decision, a relatively predictable decision, the only one that is normally taken on the completion of a pre-designed series of steps and may have very few instances of exceptions. Hence, the information needs for such decisions are usually spelled out and gathered in advance of pre-stated decision rules being applied. Thus, highly structured decisions can be made through computer programs which can then be analyzed by the concerned management people. In less structured systems, the general decision making can still be computer programmed while the exceptions can be left for human intervention. On the other hand, an unstructured decision isn't routine or predictable. It is one that occurs infrequently and hence does not justify the development of a pre-designed series of steps. By and large, the information needs to make such decisions are not known in advance and hence cannot be effectively programmed. The information has to be extracted from the information system. The nature of information required by a manager is also closely related to the organizational level of his profile. In small organizations with few managerial levels, all the managers tend to be generalists. In larger organizations, however, people with a specialized knowledge are hired and additional levels are created. The information needs of generalists are often not relevant or useful to specialists. Thus, people at different levels need to be supplied with different types of information. Top-level managers must have a general understanding of the organization's activities and are responsible for the maximum risks and major policy matters. The information supplied to them should be in tune with addressing long-range strategic plans and major decisions. Middle-level managers are responsible for making those tactical decisions that will allocate resources and establish the control needed to implement the top-level plans. Hence, the information supplied to them must be relevant for tactical decision-making. Lower-level managers make the day-to-day operational decisions to schedule and control specific tasks. Hence, the information supplied to them needs to be detailed and relevant to the planned operating tasks. One can see from these descriptions that at higher levels, information needs are as listed here. As one moves into lower levels, the information needs are as shown here. While a manager knows what kind of information he needs to take the appropriate decisions, he must also know how to go about getting the relevant information. A manager requires information in order to successfully perform his job responsibilities, which can be generalized into the following tasks: to set, assess and modify goals, draw up plans and standards and initiate action, measure individual performance and take appropriate action when performance deviations take place, evaluate individual achievement. In extending this generalization, we see that the manager needs to deal with critical success factors. Critical success factors are those issues that are vital to the manager's success in contributing to the achievement of the organization's goals. For this, the manager performs the following analysis to obtain the information he or she needs. Let us now discuss the issue about what characteristics information should have. Generally speaking, any information that helps to eliminate elements of uncertainty in decisions is of a greater value than that which serves no purpose. Hence, quality information is one that possesses the qualities listed here. In reality, however, compromises are often made in one or more of these properties due to economic and operational feasibility reasons. Accuracy is the ratio of the total information to the total amount of information produced over the time. The importance given to accuracy differs from application to application. For example, managers in banks may allow for some percentage of leeway, but they may insist on information that is at least 95% accurate. This is because their entire operations revolve around financial accounts and statements. Whereas a manager controlling stocks inventory may be content with information that has 80% accuracy because stocks inventory is a secondary activity. The extra time and resources he would use to ensure 100% accuracy may cost him more in the overall analysis. Even accurate information can become redundant if it is not supplied at the right time. Hence, timeliness is another important characteristic of quality information. Accurate information that arrives late is of no use for a manager since he cannot use it productively. Again, many a times, managers have felt agitated and helpless because they may have received information that may have been accurate and timely but was not complete. Scattered pieces of information need to be consolidated and put in order to form a complete picture. The goal of most information system designers is to improve integration of the facts available at scattered points in a business for furnishing managers with more complete information. Another important element of information is conciseness. Accurate, timely and complete information can also be very lengthy and detailed, requiring hours of reading and analysis. This would serve little purpose to managers who are usually short for time and need to gather facts quickly to make critical decisions. Today's manager needs concise information that summarizes the relevant facts and indicates the areas of exception to routine or planned activities. Primitive MIS systems evolved around the late 1960s when they were essentially electronic data processing systems. The simplistic report-generating EDP systems of yesteryear could not withstand the growing information needs of the current age and have since continued to evolve and grow. In any organization, the evolution for MIS typically passes through the stages of initiation, expansion, formalization, integration and maturity. It is not very easy to clearly define what a management information system or MIS is, since different organizations have different models of MIS. However, on a very generalized tone, one can describe an MIS as being a network of computer resources, procedures and access systems that an organization develops and integrates with manual systems to provide timely and useful information to support decision making. An MIS is a complete system and has many subsystems or components. These components include operational support systems, decision support systems, and office automation systems. Operational or tactical support systems have the characteristics listed here. Decision support systems or DSS have the characteristics listed here. Office automation systems are those that are not directly related to management decision making but constitute a component of MIS. This is because they help to automate much of the day-to-day office work involving number and text manipulation and typically include word processors, data communication programs, spreadsheet and presentation applications, etc. Even though MIS implementations may differ from organization to organization, most of them are designed with a certain broad structural concept in mind. Any organization can be seen to have horizontal and vertical structures in the management. The horizontal structure refers to the three broad levels of management, that is, top, strategic, middle, tactical, and low, operational. The vertical structure divides the management into different areas of technical expertise, example, finance, marketing, production, personnel, research, etc. Each of these structures requires its own and separate set of information flows. When one combines the two structures, one comes up with a complex organizational structure, and the task of an MIS designer is to develop the information flow needed to support decision making across all levels and divisions. Generally, much of the information needed by managers who occupy different levels and who have different responsibilities is obtained from the various MIS components. The information may be acquired from internal as well as external sources. While the horizontal and vertical structures provided a broad basis for designing MIS systems, MIS designers have to address some specific questions while planning the system. These include questions of, should the MIS development adopt the top-down or bottom-up approach? Would the creation of a single database suffice the differing information needs of the three managerial levels? Would the same database suffice for requirements in the different areas of technical expertise? Can the database incorporate information and facts from an external data source? To what extent should an attempt be made to create a complete MIS for the complex horizontal cum vertical structure? Planning involves making decisions and designs in advance for a proposed course of action. It involves decision-making for short-term and long-term objectives as well as defining the procedures and controls needed to achieve the same. In the corporate scenario, the process of creating an MIS and then adapting it to changing conditions is a complex undertaking. It requires careful and frequent planning by MIS managers whose main goal is to see that human and technological resources are utilized in ways that best support the organization's strategies, goals, and processes. Many organizations have a MIS master plan to allocate and control information resources, which is coordinated by a person called a Chief Information Officer or some such equivalent. This master plan can take the shape of a 1-year short-term plan or a 3-year long-term plan and typically covers the following topics. Since information and organizational needs keep changing and firms can also have unexpected developments, this master plan needs to be reviewed periodically to handle these exigencies. The focal point of this chapter has been that MIS helps in decision making and planning. Let us now see just how an MIS can affect the quality of the manager's plans. The following roles of MIS are vital for planning. They create quicker awareness of problems and opportunities through exception reports for deviations and summary reports for analyzing past, current, future trends. They allow the managers to devote more time to planning by reducing paperwork and providing concise information. They permit managers to give timely attention to more complex relationships through concise reports, DSS tools, and graphic charts that provide vital planning information of probable economic and social outcomes of different courses of action. Assist in decision implementation by providing the basic information for creating subordinate plans, scheduling charts, allocation of resources, etc. needed to implement decisions. It is evident now that most managers in any business area resort to computer-based MIS to regularly support their planning and decision-making activities. Among the many planning practices supported by the DSS component used by managers are simulation, expert systems, and information centers. Simulation begins with a theory that is then designed on reality and actual facts to make a working model. This model is then used to test the theory and attempt to identify and/or reflect the behavior of the real people, processes, or systems. Simulation models are useful for all levels of management. Top executives can study the simulation and take important decisions. Middle-level managers also benefit with simulations that help them make tactical decisions that arise out of conflicting desires of various departments within an organization. Such simulation models can also be integrated into an overall corporate modeling approach to planning and decision-making. One must remember, however, that the result of a simulation is dependent on the facts and assumptions of people it was designed on. Expert systems, as you may recall, are a result of research in the field of artificial intelligence. As the name denotes, an expert system tries to attribute intelligence to the computer by giving it access to huge databases, programs it to consider all the possibilities that can be considered, and thereby equips the computer to suggest possible decisions. In short, an expert system is a software package that includes a stored base of knowledge in a specialized area. An expert system shell that is able to probe this knowledge base and make decisions and recommendations. This serves as an important MIS practice since it is able to analyze and consolidate all the facts and possibilities at record time and provides a possible decision approach that may not have been considered by human effort. Another decision-making practice supported by MIS is the Information Center. It is usually set up as a service branch of a MIS department, and its role is to give users a direct online path to the organization's databases to retrieve the facts they need. The personnel in these centers educate managers on how to employ 4GLs and other database query languages to extract information for their customized reports. Thus, information centers allow end users to achieve a level of self-sufficiency by generating information reports for their own decision-making rather than burdening analysts and programmers of the MIS department for the same. Apart from planning and strategizing for the future, managers have an important role in performing control functions for operations of the past and the present. MIS helps in management control by allowing managers to follow up the planning and check on past or current performance to see if the planned goals are being achieved. This control process is based on the following steps: setting goals or standards, evaluating actual performance, comparing actual performance with set standards, making appropriate control decisions. In such a scenario, the MIS must be able to generate managerial control information for the manager, which is required to monitor the operations they are responsible for. The output of MIS can help managers in control practices by enabling them to set more realistic standards, summarize actual performance data promptly and accurately, make detailed and accurate comparisons, and carry out predetermined structured decisions. Thus, by taking away the burden of routine operational controls, MIS output allows the managers to devote more time to planning and strategy. Management information systems have certainly had a positive impact on our lives, but they are not devoid of certain issues that relate to organization, controls, and social impacts. Organizing involves grouping human and other resources into logical and efficient units to implement plans and achieve goals. In designing and implementing an MIS, one is often forced to reconsider several important and interrelated organizing issues which are listed here. The answers to these questions can vary, and what may be the right answers for one organization may be unfeasible for another. Centralization of authority refers to the concentration of the important decision-making powers in the hands of relatively few executives in an organization. Decentralization of authority refers to the degree to which decisions are taken at lower levels. In this regard, an MIS can be seen to complement centralized control, since top management can be given timely information from scattered departments for timely and appropriate action. This does not mean that MIS reduces the need for decentralization. Rather, that the degree of centralization or decentralization depends more on company philosophy rather than the information need. With respect to data processing, one sees that an organization's decision to have centralized or decentralized data processing depends on their choice and available resources. Reduced hardware costs and efficient data communication systems allow for organizations to opt for either approach. Centralized data processing is used to process data originating at all the user points, while decentralized approaches allow data to be processed by individual users. The more an organization tends to move towards centralized data processing, or at best a distributed data processing system, the more easy it will be for it to attain the following benefits. The same can be said for storage of data. The decision to adopt centralized or dispersed data storage also depends on the available resources. Although, with improved data communications and DDP networks, many organizations are deciding to what extent they need to relocate previously centralized data storage to user location. Centrally located data storehouses can be accessed by PC users or terminal users, but such systems need very intricate access and security checks to ensure central data files are not tampered with or contaminated with user data. Now, we come to the location of computer resources. This does not refer to the millions of PCs on desktops the world over, but the location of the main computing facility within an organization. Historically, most computing systems were developed for financial and accounting departments. Hence, in many organizations, till today, the computer resources are housed within the finance department under the control of the finance manager. The second type of location is seen in computer resources being placed in a service center that is established away from the mainstream operations under a center manager reporting to a neutral boss. Such location systems typically did not initiate any new systems because of their status, and again provided a very confusing view for MIS effort. The third and most effective location is seen in the setting up of a complete information services department with a high status. Such systems were designed to provide impartial service to all users' needs and was under the control of a senior person, like VP Information Systems or Director MIS or Chief Information Officer. Because of the status and position of the center head, such locations typically initiated new applications, designed better MIS, and provided a better integration of information resources. Finally, we come to the organizing issue of how the MIS department should be structured. MIS departments can be organized in many ways and depend on how organizations have reacted to the other organizing issues. Typically, an MIS requires the technical expertise of a database administrator or a DBA, who sets and controls the definitions of data items within the firm's DBMS, defines relationships between data items and ensures database security against unauthorized access. In addition, the program preparations and maintenance is handled by another group of technical people. The System Analysis and Design group forms the crucial link between user groups and other sections within the MIS department. The Operations group performs the routine input data preparation and generation of output. It is from this that the term Operations Research or OR comes about. OR includes all the quantitative methodology, designs and knowledge used to help managers make decisions. The OR team members comprise computer operators, input-output device operators, and media librarians. Additionally, the convergence with computing and communications technologies has shown a growing tendency to place telecommunications functions also as part of the MIS department. So, the MIS department houses all computer-based functions, be it operations, telecommunications, information center, system analysis and design, or database administration. Since all these handle information resources, today the term used for such activities is IRM or Information Resource Management. The implementation of MIS has a very significant impact on various kinds of control issues: internal control, production control, and MIS control. Internal control issues constitute the rules and procedures that are followed to maintain the integrity and security of data, records, financial assets, and other resources of an organization. In earlier systems, the organizational structure separated the various people involved in handling of one activity. Example, a customer's order processing. One group may have handled the inquiry, another may approve the customer's credit limit, yet another would provide stocks inventory, a fourth group may do the billing, and finally another group may receive the payment against the shipment. In such systems, the involvement of so many people and departments typically check the potential for fraud and deception. This was the system of internal control by which each independent group was able to review and cross-check the others. The introduction of MIS systems promoted the processing of all these steps to be integrated so that they were performed by at best one or two groups only. With reduced involvement of departments, it may appear as though MIS was reducing the importance of internal controls. Hence, the MIS has to be very efficiently planned and must consider the following issues when being designed. Designing system-oriented controls via programming can ensure this, and separation of duties for control within the MIS can control the systems in turn. It is agreed by everyone that better control can be achieved by computer usage because of the factors shown here. Today, almost all except the smallest businesses use computer-based systems to handle scheduling and controlling production. Material Resource Planning or MRP and Manufacturing Resource Planning or MRP2 are examples of computer-based systems used in production and manufacturing in use since the 1970s. Despite these effective systems, there are two issues that bother managers: the inventory control system and the quality assurance system. Inventory control is the process of balancing the levels of raw materials, work in progress stocks, and finished goods against the costs of maintaining those levels. While computers are used for inventory decision supports, there are important inventory issues that need to be considered. What is the level to be maintained is the question. Some organizations use the Japanese JIT or just-in-time approach, which keeps a minimum level of materials and parts in stock and then supplies them to the production floor just before it is needed. The JIT system depends on a sophisticated MIS that can track production rates, inventory levels, and incoming orders. An MRP2 scheduling and control subsystem can complement this by linking producers' computers to the suppliers' computers to enable vendors to meet shipment deadlines set by production schedules. Quality is a relative term, but is generally judged on the basis of the strength, reliability, maintainability, and aesthetic features of a product. In the realm of quality assurance, MIS systems should be able to handle critical issues that would ensure the quality of a product. This involves quality planning and quality control. Quality planning defines the quality characteristics, defines how it is to be measured, and sets the quality standard. Quality control establishes the inspection program and evaluates the result against the preset standards, as well as identifies and removes the causes of poor quality. Some of the MIS practices that are used to ensure quality are the Zero Defects program and the Automated Inspection Station. The MIS manager, irrespective of what his tag is wholly responsible for countering data integrity and system security threats. The controls that he exercises in the MIS department must ensure operating efficiency and high team motivation. Some of the data integrity controls are listed here. Operating efficiency controls can be obtained through the measures listed here. Team motivation includes ensuring a steady team and high level of job satisfaction. Typically, fast turnover of skilled employees is a continuing phenomena in the computer industry. MIS managers the world over have a hard time locating, training, and replacing people who leave the organization. Hence, the MIS managers can exercise some control over ensuring team motivation and satisfaction by addressing the issues listed here. A better match of the employee's needs and the organization's functions can be obtained by employing carefully planned skills upgrade programs. It is obvious that the introduction of MIS and the resultant omnipresence of computers will have significant impact on society. There are certain social issues related to the use of information systems. Job-related issues cover the human work environment issues. The introduction of computer-based systems has led to a drastic displacement and unemployment among people, particularly in the lower operation and supervisory levels. The extent to which displacement occurs and the significance of problems in particular cases may depend in large measure on the factors listed here. With respect to location of work, you are already familiar with the fact that telecommuting concepts and telecommunications networks have allowed for flexi-time work scheduling and work-from-home concepts. Finally, the most critical issue of introducing computer-based systems is that of resisting change. People resist changes in different ways. They undergo feelings of job insecurity, reduced social satisfaction, reduced self-esteem, and reputation. The best way to handle this is by keeping them informed and allowing greater employee participation. People are often confused and bewildered by computer data input procedures. This is largely due to the fact that they are not told what is expected from them or how the system works. Hence, much of the confusion results in people tending to believe that the computerized system was responsible for tricking or deceiving them. Additionally, the process or standardization achieved by computer usage has also in some ways led to unwanted depersonalization. The national and social identity of every person today has been reduced to a code number comprising alphabets and digits. Attempts are being made to arrive at a universal identifier that can track a person anywhere in the world. The attempt to try and fit everything into a standard mold or a standard set of norms has led to people feeling aloof and remote from the organization. Finally, we see that MIS systems have virtually dissolved national boundaries in the way they link computing facilities all over the world. International airlines reservation systems, global news agencies, multinational companies with their networks have all led to efficiency in international communication and decision making. However, they may also increase the tension amongst nations and the companies that may operate within their boundaries. The issue of trans-border data flow is a debatable one that many nations are contemplating. Many of the northern European nations have imposed data protection laws, which, in the eyes of multinational businesses, appear to be forms of trade restrictions and obstacles for free scientific and cultural exchange.